Okay, this is Mr. Long, and I'm here with my third period class, and we're going to talk about classifying chemical reactions. So there are 5 main types of chemical reactions that I'm going to talk about today. And this first one, number 1, will be a synthesis, sometimes called formation. And so we have A plus B comes together to make AB. So they're coming together, they're getting married, and they're going to be together. And so there are some examples that we could have here. For example, we could have calcium oxide, which is a solid. So that's what these letters will stand for in the parentheses. And it reacts with, so when you see "and," you're going to say reacts with water, which of course is a liquid, so that's an L. And that's going to produce calcium hydroxide. Now, when we see OH, think of a base. This is probably going to be a base. And that's at the end. If you see something, if you see an H as an HCl, this is going to be an acid usually. So when you see OH, think it's probably a base, and you see something at H in front of something, it could be an acid, or will be an acid. So they come together. And another one could be sulfur dioxide. How would we write sulfur dioxide, guys?
SO2.
So SO2 reacts with oxygen to produce 2SO3. So they're coming together. This is 2. So sometimes you'll have your equations balanced for you, and sometimes you won't. And now a second kind of reaction is just the opposite.
Take them apart.
They're going to break up. Okay, so they call it a decomposition reaction.
Don't some people call it desynthesis or something?
Analysis. Okay. And this would be, we'll have this as AB. They're already together, and they're going to separate into A and B. They're getting a divorce. Okay, and examples of this could be ammonium nitrate. Now, how will we write ammonium nitrate?
NO3.
NH what? Ammonium. NH4. Nitrate.
NO3.
NO3. It's a 1-to-1 ratio, get +1 and -1. Okay, and that's going to be in solid form. This is farmer's fertilizer, the one that explodes. And that's going to make dinitrogen monoxide, N2O, which is a gas, and water vapor, 2H2O gas. And this is a gas, and that's a solid. Okay, and another example could be, well, that's good there. Or we could have, let's say, 2NaN3. Okay, and that's going to break down, because you see the arrow there, to 2 sodiums plus 3 N2s.
What is NaN? Is it a gas, solid, or?
Okay, it's a solid, sodium nitride, and this sodium is a solid, of course, which you guys just got through playing with in the lab. 2, 2, and 3, and of course nitrogen is a gas. So decomposition on there. Now let's go to a third kind.
Pull it down.
And that's going to be single replacement. Okay, and this is going to be where we have A plus BX, and that's going to produce AX plus B. Now the way I look at this, you have two competing either cations or anions, okay, and one of them is going to be more active than the other and it's going to replace it. So A gives B the boot because it's more reactive, and then therefore A gets the cheese. And remember, we always write the positive one first, so this is positive and this is negative here. So both A and B are positive. Now, an example could be lithium and water. How would you write lithium and water? Li plus H2O, and lithium is going to be a solid, like sodium was, and we know what water is, a liquid, and that's going to make lithium hydroxide. How would we write that?
LiO8.
Okay, very good, and that's aqueous. AQ means it's an aqueous solution. What does aqueous mean?
Water?
Water, like agua, aqua.
What's the difference between liquid and water?
Well, this means that I know what you're saying. Okay, in water, this separates into the lithium plus and the OH minus ions, and you get water molecules surrounding them. So it's dissolved. So it means it's dissolved in water. Okay, and what might our other product be? Just like in our sodium and water lab?
H2O.
Not H2O.
Hydrogen.
Hydrogen. Okay, gas. Okay.
Is it important to put down what type of form it's in? Solid,
Yeah, like
liquid, gas,
AQ.
Well, we won't write it every time, but I want you to get used to writing it and seeing it. Because, you know, in AP, that's all they do.
What is the purpose of doing it for this certain thing that we're learning?
It's just learning to write the states of matter with the reactants and products. It's helpful. Okay. Now, another one. Now, we have copper, solid copper,
Pull it down.
and we are going to talk about word equations today. Okay, solid copper, and it reacts with silver nitrate. How do we write silver nitrate?
You pull down again.
AgNO3.
AgNO3 is correct, Kaylee. Very good. Okay, so copper is a solid, and silver nitrate is dissolved in water, so we put AQ. Okay, and it's going to produce solid silver plus copper 2 nitrate. And it's copper 2 because we have 2 nitrate ions, like that. And that's going to be aqueous, AQ.
How do you know if something's aqueous or not?
Basically, from your point of view, you're going to have to be told. We'll have to be told on that. So,
So why is there a 2 after N3?
Because it's copper too.
because it's copper 2. Remember, copper's...
Why is it copper 2 on the other side?
Well, sometimes these things put copper 2 on there. Sometimes it might be copper Roman numeral 2 or something, or it might see this. But you would have to know that it's copper 2 to write that product. You would have to know it. Okay, or you'd be told it. Okay, either in the words or in the reaction. Okay, so we got one element coming in. Now there's something called the activity series of elements, and elements are listed in order of reactivity, and copper's higher on that list than silver. So copper's more reactive than silver. So copper's going to get the cheese, which is a negative anion. Copper's a cation, and silver's going to get the boot. Okay, a single replacement. Number 4 is going to be double replacement. Sometimes called double displacement. Double dis. Okay, and where you have two compounds reacting with each other. So what we'll have is, on our general form, is AX plus BY, and they're going to swap partners to make AY plus BX. So this is positive, this is negative, this is positive, this is negative. Okay, so that this positive is going to hook up with this negative, and this positive is going to hook up with this other negative. So they're swapping partners. Okay, and it's pretty easy to see on equations. And a couple examples of that, we could have an acid-base reaction. We could have calcium hydroxide. And how do we write calcium hydroxide?
CaOH.
Are you sure? What is?
COH.
Hey, someone besides Justice can answer these questions. Oh, is it lunchtime?
Yeah.
All right, we'll stop it here and we'll pick back up after lunch, guys. Very good.
Why are you trying to confuse me?